Okay, well, welcome along, everybody. I'm Mike Frost. I'm the meeting secretary. Our chair, Carolyn, is here tonight, but she's taking on John Tutor's role as the webmaster and keeping an eye on the waiting room and introducing the speakers. Probably it's Ask Qubit. So I've taken on the role of introducing our speaker tonight. Can I just do a couple of housekeeping announcements? We'll mute everybody when the talk starts. If you we save questions to the end, if that's okay, Karen, and or put them into chat so that so the questions are waiting for the end of the talk. It is my pleasure to welcome along tonight Professor Karen Masters of Haverford University in Pennsylvania, near Philadelphia in the United States. Karen is a observational astronomer. She's studying the structure of galaxies. She started out, as we were just discussing, if you heard our discussions a few minutes ago, started off as an undergraduate at Wadham College, a place dear to this society where we were formed 22 or so years ago, and where Dr. Alan Chapman, our founding father, honorary president, patron saint, and everything else, it comes from. Karen moved on to do postdoc work at Cornell University in the United States, and then came back to the UK to become a lecturer at Portsmouth University. But she's now crossed the Atlantic once again to take a professorship at Haverford University, as I say, Pennsylvania, and on the eastern side of the United States. A speciality is structure of galaxies, and from what I've read, involved with the Sloan Sky Survey. It's called MANGA, which I'm sure she'll explain to us at the end of the talk, and also the Galaxy Zoo, which I'm sure is familiar to many of us. I spent many a happy hour classifying galaxies on there. But she also has an interest in the history of astronomy, and tonight she's going to tell us about the Astronomers Library. My pleasure to introduce Karen Masters.
Thank you very much for such a nice invitation and a nice introduction. And it's my pleasure to be here. I have to admit to some nerves presenting to this group. I don't particularly consider myself a historian of astronomy, although if you've had a chance to look at the book, or if you look at it in future, you'll see I do find it kind of fascinating and interesting. I do enjoy it. And I had a great deal of fun working on this project for this book, which kind of landed in my lap as this beautiful project. If I, whoops, how do I make this work? There we go. So this was a book that I did with Quarto Publishing. It's actually the third book I've done with that group. They're a British-based publisher, and they sort of commission books. So the previous two I did were in their 30-second series that I did in collaboration with Charles Liu and some other people. This was the first one I did for Quarto by myself, but they kind of approached me and said, this is the title, this is the book we'd like you to write. And then at that point, it just sounded like the dream project. I've always loved books. I think astronomy is fascinating, and they kind of left it to me to structure it how I liked, as long as it fit the overall brief. So that was really delightful. And as a commissioned book, it came with this whole team who really made just a beautiful book. And particular shout out to Roland Hall, who works in London, and was my editor, but also, did a lot of the design. So if you do get the book, and I should say, I don't get a commission per book or anything like that. So it's lovely if you buy it, but it doesn't impact me financially at this point. You'll see it's just a really, really attractive book. They really laid it out nicely, and I was delighted to contribute some sort of modern astronomy reflections on why these are in the end, it was 101 books. These were the 101 books that we picked out that we think should ideally be in every astronomy library. The whole thing was fairly quick. I did most of the writing in the spring of 2023, and it's been out now for about 6 months or so. It's in German, if you like to read German, so that's kind of a nice surprise. Maybe it's in other languages, I don't know. I'm sort of a bit hands-off with the publishing side of things, but they sent me a copy of the German book a few weeks ago, so I know that. And as I mentioned, it's part of this series, or maybe I didn't mention, but it's part of this series called Liber Historica that the publishers do. So they're all actually quite charming historical science-related books. I have the Philosopher's Library and Scientifica Historica, which were out when I was working on Astronomers Library. And I'm pretty tempted to get the Atlas and the Botanist one, because I think those will be quite fun to look at, but I haven't done that yet. Okay, So once I get the title and the project, I sort of left to me to organize the library. And so I'll talk about a little bit about what I hit on, but a little bit about astronomy libraries that I read about while working on the project. I presume you're all familiar with Tycho Brahe's Uraniborg, this crazy sort of castle to astronomy that was built in, well, what was then Denmark, I think is now Sweden, and then got destroyed when Tycho Brahe annoyed the Danish royal family. But so the story goes, this was the first real astronomers library, or library dedicated to astronomy. You find them in a lot of observatories, basically, or buildings that are aimed at astronomy. And there was pretty much a standard kind of instrument in every observatory that was built for a period of time that you'd have a library. So if my mouse works, I think it does. You can see the bibliothèque illustrated here in the Observatoire de Paris. If I'm honest, I didn't really pay attention to how they organized their books. I just sort of thought about what I'd like to do. Initially, the publishers suggested, maybe just strictly chronological, but I felt like some kind of thematic organization might be more pleasing to read. And so I came up with these sort of 5 different categories. Star atlases, maps of the planets mostly, but I call it mapping other worlds. I wanted to really try to reach outside of just Western books. As someone said to me, where there's books, there's bias. So you can't be completely representative of all cultures if you're focusing on talking about books, because not all cultures have saved books from their records. But nevertheless, I wanted to look outside of Western European traditions. And so I put in a section on astronomy and culture to think about astronomy books from around the world. Then there had to be one that was really quite strictly chronological. Developing our model of the universe is really about like the history of our understanding of our place in the universe. So from like the geocentric models through to pretty modern ideas, mathematical astronomy. And then as I realized, as I was doing this, most books about astronomy, honestly, today for sure, but even through history, have been published to educate people. So they're either textbooks or popular science books. So there had to be a section on educational books. So that was astronomy for everyone. And then I was really nervous about what to do with recent books and how much trouble I might get in if I leave certain people's books out of the library. So I put all of the books published in the last 100 years go into modern astronomy. And I kind of took the author's privilege of just picking out some favorites in different ways. And for a talk on the history of astronomy, I might not focus too much on this last section. I had the privilege actually to work in a few places and experience a few astronomy libraries. So I was a postdoc at Harvard for 3 years at the Harvard College Observatory, which had this Woolback library, not a particularly attractive library as far as they go, but nevertheless a cool library space. Unfortunately, Harvard decided to close the astronomy library, and they've just relocated all the books into the central library. And so that was in the news, actually, ironically, just as the book was publishing. The other one that if you've never been, I hope you have, and you can make an appointment to go and see the Royal Astronomical Library. This is a really beautiful space in central London, in Piccadilly. I wasn't able to get there physically while I was working on this book. I've been before, but Sean Prosser, who works there, was very accommodating with a Zoom call and showed us some of the cool books that they have, and we got to talk a little bit about some of the must-haves in the library. So that was really helpful. And then I work in a building with an astronomy library, ironically. So this is my office in it's called the Strawbridge Observatory at Haverford College. It's this sort of little stone observatory. I have a picture coming later. But one of the really cool rooms that we have in our observatory is an astronomy library. And so this is a picture of me teaching a class in the library, some of the small classes we can do that. And then we also recently had some artwork done, sort of inspired by astronomy and put on display in our library. So had a lot of nice examples. Haverford also has a really beautiful special collections. And, it's a pretty small college. It's one of these small liberal arts colleges in the US. You might have heard of places like Wellesley or Vassar. Haverford's kind of along that line of type of places. And so we actually have a copy of Principia. We have De Revolutionibus. We have a bunch of really cool old astronomy books that I can go and check out. So I think it was in a great place to be working on this. I assume that Owen Gingrich came here and had a look at our De Revolutionibus. I don't know for sure, but he said he went to see all of them, right? So must have. All right. So again, so this was my layout, and I'll just sort of talk through some of my favorite books and favorite bits that I put into the book. So we started with star atlases and this realization that actually the first star atlases aren't even really in books. Some of the longest living ones or longest lasting ones that we have historically are on metal. Like, well, I mean, so there's some debate, I guess, as to whether or not this Bronze Age, I'm losing the Nebra sky disk. I was losing the name for a moment. Some debate as to whether or not this really counts as a star atlas. It certainly appears pictographically to represent stars from 1600 BC Germany. There's a lot of these metal astrolabes from the Islamic Middle Ages. This example is from Northern Africa. 2nd century Greece, the statue of Atlas is supposedly the first representation out there of the Greek constellations. So not exactly a star map, but definitely representing the mythology of the Greek constellations. And the oldest existing paper star atlas out there, as far as I could find out, is this one from Tang Dynasty, China. It was part of a collection of manuscripts that was found in a desert cave in China, dating back to sort of 900 CE, so very, very old indeed, but not exactly what we'd call a book. To get to the first or the oldest sort of books that contain star atlases that you might keep in your library, the book of the, see the zoom things are over the words, the book of the images of the fixed stars. Yes, I want to make sure I get it right. This was originally published in 10th century Persia, so there's no original copies that remain. I learned, and this will come up over and over again. There was this Islamic tradition of copying manuscripts. So the medieval Islamic world, scholars would sit and copy manuscripts. So many copies of this exist, and they are dated very accurately back to, I think it was something like 964. I'm not very good at remembering numbers, but there's a very precise date based on the positions of the stars and based on our understanding of the precession of the equinoxes. So that's quite pleasing, right? You can really date this very accurately. And what al-Sufi did, who lived in what we would consider Iran today, was make these star charts that merged the Greek traditional constellations with the Arabic traditional constellations. So they kind of somewhat look familiar, somewhat look quite different. And so here we have a woman, and some of you will probably instantly recognize this as Andromeda, and also a fish. So the fish is the Arabic constellation in this part of the sky, and obviously Andromeda from the Greek tradition. And they're overlaid like this. And one of the things, though, that really struck me about this was the little fuzzy bit at the nose of the fish. I like galaxies, as Mike introduced. This is my area. This is the first book that shows an image of a galaxy. It's not a great reproduction of what Andromeda looks like, maybe, although not too bad. The sort of naked eye version of it kind of just looks like a blob, right? But I had no idea until I was researching for this book that we had such old records of the Andromeda galaxy. So that was cool. So we're going to fast forward a bit to the first printed books. So Della Stelle Fis is pretty fun one, Piccolomini. I really like this one because he published it in Italian. So it was published to be accessible. It's also the very first sort of representation of constellations. So like each constellation has its little chart so you might be able to use it to kind of identify things in the sky. So it kind of seems kind of familiar to how, you get constellation maps today. He also gave stars letters. So these are not Greek letters, but starting this tradition of lettering the stars in a constellation from brightest to faintest. And he dedicated it to his friend / lover, unclear, a woman, a poet who was a woman, with statements about how he believed she should be more interested in astronomy. And as a female astronomer, I found that quite pleasing too. He's really trying to bring people into astronomy and encourage involvement. So that was nice. And Haverford actually obtained a copy of this while I was working on the book. I think that's a coincidence, or maybe I was raving about how cool this book was to our special collections curator. But in any case, so now we have a copy of this, so that's quite fun. Hopefully you have all seen images like this, or if you haven't, I encourage you to go and look up Harmonia macrocosmica. There's quite a few plates from it in my book. But honestly, a lot of the research I did for this book, and maybe you all are super well aware of this, but there's an enormous number of digital scans of these books that are completely free access. So like the Library of Congress has them and other portals that scan books. And some of them have really good quality scans, so you can go and enjoy the images. And so this was a book made in the Dutch golden age of cartography. And supposedly these giant atlases were made at a complete loss so that these publishers could demonstrate what they could do. And then they made all of their money off of little pamphlets and poetry and little things. But they made these enormous, incredibly elaborate atlases of various things. And this one is various atlases to do with the night skies. Not just actually star atlases, we'll see it come back later when we're looking at some maps of the universe. But this star atlas in particular attracted my attention. And I don't know if you've spotted it yet, if you can look that closely, but it's not Greek constellations at all. This was, and it's sort of given away in the name here, this was a illustration of an idea that maybe it would be better to have Christian saints in the night skies. And that would be more in line with European thinking of the 1600s, that you'd move on from the Greek mythology and instead have Christian saints in the skies. So I'd never heard of that thought, but it kind of fits nicely with the idea that I tend to teach to my students, right? The constellations are completely arbitrary. They're completely a human construct. I mean, they're kind of convenient to navigate across the skies, but you could do whatever you like with constellations, and lots of different cultures have different choices. So I enjoyed that. I also really enjoyed the cherubs in these illustrations, and I think it's something we should bring back into scientific illustration today. Probably wouldn't get away with it. So not just cherubs, sometimes the corners are showing like how they made the maps. So here we have the astronomers using sextants to measure presumably the angles on the sky, including sitting on this roof. A friend of mine who I was showing this to as I was enjoying it pointed out they don't have great skies for doing this. They're under cloudy skies doing their star mapping. And the cherubs themselves are getting involved and have sextants. So that was quite pleasing. Hevelius seems like an interesting character. He was a Polish astronomer, and he was not a fan, supposedly, of the telescope. And so he made the cherubs in the corners of some of his star maps, kind of technical comments. And so here the words translated from Latin say the eye is better. So this cherub is trying to hand them a telescope, and they're saying, no, we're going to use this sextant to do the measuring. And so this firmamentum sebestium sivu anagraphia, I'm very bad at Latin, so apologies for mangling it, was the last non-telescopic atlas that was ever published, the last really large-scale non-telescopic atlas. I think, if I remember correctly, 5 of the current IAU official constellations were invented in this one. So it's kind of significant for that, although, as I mentioned, constellations are a little bit arbitrary. So now we're going to move on to telescopic atlases, and here get some British involvement for sure. So this is, the era in the 100 years following the invention of the telescope, where all of the big governments, mostly royal families in Europe, are building fancy observatories because they've realized that navigation by the stars can help them, make money basically off of navigating the globe and become global superpowers. So of course the UK was a big part of this, and here is a picture of Greenwich Observatory overlooking the Thames, and sort of indicating how it would signal the noon hour. In fact, I think they signaled the 1 p.m. hour to the ships because the ships were busy marking local noon at noon. So they got 1 p.m. from Greenwich Observatory, and then they set off with their clocks set so they can measure their longitude as they go around the Earth. And so John Flamsteed, the first astronomer royal, worked hard to map the skies with the telescope from Greenwich. He also sent a bunch of astronomers all over the place, including, I think, Edmund Halley went to the Southern Hemisphere. So this is the first telescopic atlas. The work putting it together took over a decade. There's all kinds of stories, which I found kind of cool, about how Flamsteed sort of delayed publication. And it was the first real big publication of the Southern Hemisphere skies in the Northern Hemisphere, coming from these astronomers who went into the South. So that one had to be saved. And at this point, this is where I put my observatory in again. So this is actually a really old picture of the Haverford College Observatory. And here it is this past summer. So this is me with some of my students. So this is where I'm sitting right now. It's kind of the other side. This is what would become my office. And then they built out a classroom on the back of this original observatory, and this hexagonal building, excuse me, is where we put the observatory. So the extension was all built in the 1930s. But what was fun, and kind of linking back to these, the great telescopic atlases and the atlases for timekeeping, was that this other side of the observatory originally had a transit telescope for measuring the times that stars go across the meridian. And this little chair is still in the basement here. One day I'll dig it out and figure out how to get it renovated and put somewhere more interesting than just stuck in the basement. But there's a lot of history in this building, which is kind of fun. I'm pretty sure that, I haven't never found anything that looks like this telescope, but the basement's pretty big, if I'm honest. We do have some of the old telescopes knocking around. There's a really big refractor with the lens removed in the classroom that people enjoy. Apologies, I don't think I have a picture of that. But it's sort of a fun place to work because there's a lot of history around me. Anyway, I'm figuring, so this talk has a mixture of slides with some lessons about astronomy. I think I'm going to skip over, why measuring the times that stars cross the meridian is good for timekeeping. I have it in for other audiences, but in the interest of time, we'll skip that. So I ended the section on star atlases with sort of a reflection on how they're used today. So I included this example from, I think, the IAU's official publications of atlases. I can't quite remember where it comes from, but in any case, sort of this very digital version, the stick figures, and really sort of reflecting on the fact that many professional astronomers don't really know the constellations because we mostly just use the coordinates that we enter into a computer. But also I included a little bit about interest in constellations from other cultures. So I got really struck by these beautiful illustrations from Annette Lee, who's a Canadian astronomer. I think she's Canadian, who was part of or very interested, and I think part of the Ojibwe Nation, which is a Native American nation, and makes these beautiful illustrations of Ojibwe constellations. So this is the Wintermaker, which you might recognize as looking quite a lot like Orion. Unfortunately, we couldn't get the rights, or couldn't afford the rights to Annette's artwork for the book, but we were able to put some cave art in with similar illustrations that was open source. So again, some of the Ojibwe, or a little bit like that atlas, the statue representing the Greek constellations. This is not quite clearly a star atlas, but it appears to represent some of the mythology that is used in Ojibwe star atlases. And then I just a note that it's quite fun to think about all the different ways people put constellations together. And so there's this really cool website called Figures in the Sky, where you can go and put in some of the bright stars and look at all the different constellations that star has been used in. So again, sticking with Orion and Betelgeuse, you can see here's the Wintermaker, the Ojibwe one. And it's kind of interesting how often this part of the sky is a figure of some kind, a person. I enjoyed that. Anyway, so we're going to move on to the next section, which was about maps of the planet for the most part, mapping other worlds, I called it. We'll start with the sun. So probably pretty famously, you're all aware of Galileo's first telescopic drawing of sunspots. There was this charming illustration of Hevelius's workshop that I found in a book. So Hevelius was the one with the, I don't want to use a telescope, the cherubs saying the eye is better. And so you can see, indeed, it's got a lot of the more traditional sextants and cross staffs for measuring the skies, but obviously starting to warm to telescopes is using a telescope to project an image of the sun onto this little screen so that you can look and draw sunspots. Obviously, the safest way to try to do this. But one thing I learned, and there's a really neat article in, I think it's in Astronomy and Geophysics, about this ancient record of sunspots from the UK. So this is John of Worcester in 1128. I had no idea. But apparently there's quite a lot of records, or maybe quite a lot is not fair, a handful of records of pre-telescopic observations of sunspots, either done through sort of atmospheric conditions that mean you can look at the sun, although it's not advised to do so, and not always recognized as sunspots at the time, often like presented as transits or sort of this confusing atmospheric phenomena or something. So not, someone asked me a really interesting question, you know, how come if we knew about sunspots in 1128, the 1600s work of Galileo was such a surprise? And it seems like it was just largely dismissed as not really significant. And it was mostly not astronomers doing it. John of Worcester was not an astronomer, was just interested in chronicling history in general. So it just seems to have kind of not been noticed that there were, from various different places in the world, records of sunspots, even well before Galileo. But I found that interesting to learn about. Also interesting, and something that I discovered in the Haverford Library in special collections was this illustration of the sun, which I think is entirely fantastical. I think it was made up. I think it's sort of imagining the sun as a world, because it was done in 1675, which I think is well before anyone knew about prominences and sunspots and granulation and all this kind of stuff. But it really just struck me how much this illustration looks like a sort of modern H-alpha image of the sun, where you can see all of the convection cells and the prominences and everything going on. So I really enjoyed that, and I keep meaning to come back to, where did this come from? How did they make this? Because I don't think this was based on any observations, but it's kind of presumably just a nice coincidence that it looks a lot like the sun. I enjoyed that. This is a cool book. This is The Sphere of Marcus Manilius, and it's like a poem written by Marcus Manilius, and then Sir Edward Sherborne wrote a bunch of like astronomy, like it's almost like interpreting the poem, like what the astronomy was in the poem. So there's all kind of interesting stuff in it, which I don't know as much about as I'd like to, but it was neat to look at. Okay. So at this point, I have this reminder of our view of the moon, which I presume you probably all know, right? That we see the moon in reflected sunlight, and that we see the same side of the moon always pointing towards the Earth. So just sometimes it's lit up and sometimes it's not. So that was meant to kind of reflect on the fact that the first, books that we have that report maps of the near side of the moon really are, when you really start to think of it as a map when it's telescopic and it starts to show very detailed features. So Galileo's Sidereus Nuncius from 1610, his collected kind of observations, first observations through the telescope, showing these beautiful images of the moon, which clearly you all are very familiar with because you have it at the top of your website. So that was neat to see. But then if you want to get the first maps of the back side of the moon, the side that doesn't face the Earth ever, we have to go to the space age. And so this is a photographic image that came back from Luna 3 in 1959, was the first image of the far side of the moon. But Hevelius gets in on the act here, so I enjoyed this. So this is Hevelius again. He doesn't like telescopes, except look at the telescope he built. I've just thought this was really wild and really made me think about how there really just must be no lights from this little city or town at all. And also made me think, makes you think about how for a telescope, you don't need the tube. The tube's just there to keep light from getting into the system. What you need, and to keep the lenses lined up, right? And so he's made this telescope, which is just, the lens is just lined up, but without a tube, which you can use if it's dark enough. And presumably was somewhat easier to construct. It must have been incredibly fragile, been cool to see. But anyway, I enjoyed that. And what he did with this was make the first map of the moon that showed libration. So my little cartoon illustration of the moon, you're always seeing exactly the same face. It's a cartoon illustration, but it actually jiggles a bit. And this, as you I presume know, is called libration. So you see a little bit more than just half of the moon if you observe it over a long enough period, which clearly Hevelius did. And this is the first published map of that. Again, with cherubs. Now the cherubs are using telescopes. So that's kind of pleasing. So we're starting to have some photography coming in, and some of the first photographs that are published are of the moon. This is not one of the very earliest ones, but it's quite an early photograph of the moon in the middle. And then these just charming illustrations of craters. This book overall from 1903 is quite fun to look at. Again, it's all public domain, so you can go and read it online. The moon considered as a planet, a world, and a satellite. And so they're kind of, what is the moon? Is it somewhere we can walk around? And they're kind of thinking about that. what was sort of fun to look at was they didn't yet have a consensus on what craters were. And so there's pages and pages in this considering whether they're volcanic or from impacts. And you could say this cross-section of a volcano and a plasticast model of a volcano to see if you get the same morphology as the craters on the moon. And they made all of these plasticasts of features and illuminated them at different angles to see if they understood the elevation, which is quite nice. So this is a plasticast of this crater Gassendi, and this is an image of it from the Lunar Reconnaissance Orbiter, just to sort of contrast. And I should say, as an aside, I think almost every single illustration I'm showing you is in the book. Not the little GIFs and the additional astronomy parts always, but these are all in the book. So if you want to look at them, that's sort of, you can do that. Yeah, so moving on, and you know, if you're talking about the sun and the moon, you've got to talk about eclipses a bit. And there's just an enormous number of books that get published about eclipses because they're so, you know, people all over the place experience eclipses. So I sort of enjoyed contrasting some of the earliest ones with some of the latest ones. So here, this pamphlet from 1537 illustrating how eclipses happen, which I think, you know, is pretty accurate, showing just a little patch of totality here on Terra for the Earth. And everyone loves the illustrations of the sun in all of these old books. You know, not that different though in concept to the road atlas for the total solar eclipse of 2024. Whoops, excuse me, which I did get to see from Texas. And then this book here is also an example of, it was sort of a pamphlet that was made for this eclipse in 1654 to kind of communicate to people how much eclipse they'd see in different cities around Europe. So I don't have the pages there, but it has like different versions of this moon with a face over the sun for different cities in Europe that you can pick out. And then a lot of people really like this illustration of the fella down here. He's got a telescope and he's clutching his head and is saying the masked sun is playing a joke on me. A lot of people think this is Galileo, or was a cartoon version of Galileo. I don't know. Looks plausible to me. It's kind of fun. And I just was reflecting, this again is my office. In fact, you probably, you know, you can't quite see behind me. I am surrounded by boxes of eclipse glasses because we signed up for this Astronomers Without Borders eclipse glasses recycling. And I think every location, particularly ones with the word observatory in the name, have been somewhat overwhelmed by the response. And so I think I probably have 20, 30,000 eclipse glasses in various stages of being checked for whether or not they're appropriate to save, and we're saving them. And then hopefully, it hasn't actually happened yet, hopefully Astronomers Without Border will tell me where to send them in these, at the moment they're going into the basement in these boxed up of roughly 2,000 per box. And I think I've gotten to box 5 now, so. And yeah, some of my students helping with the vetting, and we'll do some more of it because we're not done yet. All right. So we've got to talk a bit about the planets. And again, I made these little GIFs and put them in here for to explain to people why it is that we mostly end up with maps of Mars, Jupiter, and Saturn. I think I probably quite quickly jump over the fact that, you know, Uranus and Neptune, for a lot of this history, aren't even known about, but even when they are known about, they're just little dots. So they're not very convenient for mapping from the Earth. And Venus and Mercury, you know, they're very close to the sun. We get maps of the phases sometimes, but we don't really get so many maps of the surface of these features, at least from the Earth. But you end up with some really charming illustrations of Mars, particularly every 2 years. You'll notice the Earth and Mars get very close at opposition. And then 1 year later, they're far apart. And then coming back around, 2 years, they're very close for opposition. And then the time scale for this one is much slower, right? Jupiter and Saturn pretty much staying reasonably in the same part of the sky from 1 year to the next, moving very slowly through the constellations. Yeah, I think they have the time scales wrong. I think they mean 2 years and 200 years. Okay, so you get all these beautiful illustrations, and here are just some of my favorites. So Huygens in the 1600s, making these charming images of Saturn. I was kind of amused. Some of my students image Saturn. We have a 16-inch here with a CCD, and they're imaging it to practice making 3 filter images and putting them together in a computer and all that stuff. And they were like, it just looks like a blob with ears, was basically what they sent me. Are we doing it right? And of course, Saturn's, it's relatively small for the kind of seeing we get here, especially if it's a bit hazy. It's not that impressive, actually, although it's very, very cool. I hope you've all had the opportunity to show just random members of the public Saturn through a telescope. One day I'm going to record the audio of reactions to that because it's usually so spectacular. In any case, Huygens in the 1600s, obviously spending a lot of time observing Saturn and seeing the different orientations compared to an illustration from NASA, or not illustration, photographs from NASA of this happening. The other thing is Saturn's quite edge on right now, so it doesn't, anyway, the students had a lesson, that was good. Schiaparelli, of course, famously published the Canali on Mars, so we had to include that book. Mars, much, even at opposition, pretty challenging to observe from modest telescopes, and so you can kind of immediately, I can kind of understand how you might invent lines and things. But just an enormous number of books to do with maps of Mars, and you could do an entire talk on just maps of Mars, I think. Probably another astronomer would do that, but and then Jupiter had some charming illustrations as well. This one from Proctor, 1870, which was one of my favorite books for another reason, but has a nice illustration of Jupiter too. Comets get a good look in as well, not too surprisingly. So there must have been some really spectacular comets. This one in 1860, this one in 1618. And of course, a lot of the books about comets are really about them as omens and astrology, but they are still observations of comets that are recorded. So included some of those and some of these charming illustrations of comets. This one from China, 2nd century China, and the Chinese word for comet sort of translates to brush star, which I thought was quite charming. So, and also made me think about the fact that there's no way that one person saw all these comets. So it's a little bit like a game of telephone. I assume these are drawings of someone else's drawing of a comet. So that was kind of fun to think about. Okay, keep going here. So we have a section on astronomy and culture, and this was just a little reflection on all the ways astronomy it has impacted our calendars in different ways, calendars of religious festivals, the way we keep track of time. I don't know if I feel like I should have known this before I worked on the book as an astronomer, but I don't think I'd fully ingested that we only have 7 days of the week because there's 7 bright things in the sky. And if there were a different number of bright things in the sky, we might have a different number of days of the week. That seems to me kind of extraordinary still. But yeah, so each of the days of the week is named after the sun, moon, Mars, Mercury, Jupiter, Venus, and Saturn. Some of them seem obvious connections, others you kind of have to dig about linguistically and you realize why they're connected. That still boggles my mind, but anyway. But I had fun in this section reading about astronomy from different cultures. So I will admit that as a graduate student, I ended up embroiled in the Mayan 2012 end of the calendar thing. I used to write entries for something called Curious About Astronomy as an astronomer at Cornell. I was a graduate student at Cornell. And ended up on a radio show debating whether or not the world was going to end in 2012. So it was sort of fun for me to be able to write 10 years after the world didn't end in 2012 about that. But also to learn a little bit more about where the idea came from. So you might have heard of the Dresden Codex and the Maya sort of predictions and calendars. So it turns out the Mayan people actually probably had enormous numbers of books, but when the Spanish, I guess they're called conquistadors, came, they burnt most of the books, and they published them as these codexes, which are sort of like concertina folding. They're a little bit different to the kind of books that we developed in the West, but still books. 4 of them survived the conquest or the invasion, mostly because they got sent to Europe. So mostly they got saved in various European cities, and they sort of remembered by the name of the city they were saved in. So the Dresden Codex was saved in Dresden. It did get a little bit damaged in World War II, but it still exists today. And there's all kinds of cool astronomy stuff in the Dresden Codex. Actually, all 4 of the ones that were saved included a lot of astronomy. So that's kind of interesting to think about what was in the other books, but we'll never know, unfortunately. So just to kind of talk through how some of this is astronomy, the serpent here is eating the sun, or the hieroglyph for the sun. So this is just illustrating a page with some eclipse predictions, basically the predictions of when the sun's going to go behind the moon. I put the little key here. The dots and bars are a numeric system, so you can put these various different numbers. This page, and I haven't looked in it in great detail, I kind of read about people's research on this, has detailed counts of the time it takes from Venus to go from being an evening star back around to an evening star, which is roughly 2 years, less than 2 years. All kinds of cool astronomy in the Mayan Codex. So that was really interesting to read about. Staying in Mesoamerica, this is a really cool book, The General History of Things in New Spain, sometimes called the Florentine Codex. So this was a Florentine monk who basically emigrated to largely what we'd call Mexico today. You might not have heard of the Nahua people because they're more often called Aztec, but I learned that that's not a completely inclusive term for the people, and they prefer Nahua. And it's written, half of this is Spanish and half of this in Nahua. It was a collaboration, and it records all kinds of sort of astronomy, mythology, all kinds of, it's general history, right? So it's all kinds of things, but it has sections on the astronomy. And one thing I enjoyed about it was the rabbit in the moon. So I don't know if you're familiar with this idea that there's a rabbit in the moon. You know, I was brought up with the man in the moon. Here's the moon. I always find the man kind of hard to see, but I guess this is one eye and the other eye and the nose and the mouth. The rabbit I find easier now because it's really obvious ears and a face and the body of the rabbit. And the rabbit, it turned out, is in not just Mesoamerica, but also in Asia, which I find quite curious and cool. And so this is a beautiful illustration of the rabbit in the moon. It's actually a Chinese myth, but illustrated in a Japanese book, which is a series of views of the moon. It's called 100 Aspects of the Moon. It's not really scientific, but it was like, we have to have that one. So that one's in here. That was quite fun. And then other cool stuff from East Asia. I already did the comets and some other things. I think I'll skip over this in the interest of time. I tried not to denigrate astrology in this book. I tried to just kind of reflect on how much astronomy through history has been published because people were interested in astrology. So that was kind of interesting to think about. And so just a collection of these, mostly from the Islamic world, talking about a lot of these are books for educating people to become astrologers. So teaching about where the stars are in the sky and how they move. We've got some constellations in this one, and the phases of the moon. It's kind of interesting. And then I kind of ended this section with a reflection on how light pollution is destroying our connection to the night skies, not just light pollution, maybe also the large number of satellites these days. So Philadelphia is right here. We're pretty close to New York, actually. We're in this bright bit here. Yeah, so the skies here aren't great. And so obviously the constellations fade away. The campus has been trying or has been working slowly on installing more dark sky friendly lighting. And so the lampshades like this, a handful of them now are downward shining. They're still too bright in my opinion and too blue, but I am working on trying to persuade facilities that dimmer and redder LEDs would be a good choice. And we still do, this is the oldest building on campus. This is Founders Hall. It was a Quaker institution, so that you can see, if you know anything about Quakers, you can see some of the Quaker traditions in the oldest building. It's still very lit up at night. So I think I had a student do a project measuring the night skies here a few years ago. That was, in fact, I say I had them do it. They wanted to do it. I just helped them do it a bit. And I think we're kind of somewhere between 6 and 7 on the Bortle scale here, which is kind of tricky for seeing much, but that's where we are right now. And so we're kind of losing those connections. So moving on though, talk a little bit about some of the books about cosmology, which I think was probably the area I felt most comfortable writing about initially. So starting from the sort of medieval geocentric view of the world, although very much with an understanding, and this is an illustration from a medieval textbook showing how to illustrate the Earth is not flat. I think it's quite pleasing, but very geocentric, of course. We have to have the revolution of us. So I don't know if you've ever had the opportunity to see this, but it's quite a moment, or it was quite a moment for me to see it for the first time. Such a famous illustration showing the sun at the center of the solar system. Of course, a lot of issues with this model, and the circles making it not really fit the data that great. So that was kind of interesting to me, thinking about how science has changed. It was really just an idea, but it was a good idea. And some beautiful illustrations of this stuff. So again, back to the Harmonia Macrocosmica, here's the Ptolemy's universe, so the geocentric universe. And there are no, I didn't know this, but you've probably heard of Ptolemy's Almagest, which was the publication of the geocentric universe. There are no existing copies of that, which is kind of interesting. No original copies of it. And then we've got Copernicus, or a version of Copernicus in Harmonia Macrocosmica as well. So of course, at this point, we have to bring in Galileo, and I collected a few of his books. I mentioned Sidereus Nuncus before, the illustration of observations. It's a little bit of a collection of observations, which I assume I don't need to really explain the significance of in this audience. But I enjoyed this book a lot. The dialogue concerning the two chief world systems. I think Galileo must have been a real, real good public communicator of science. I'm thinking about him dropping things off the Leaning Tower of Pisa to illustrate gravity as well. But this is a play that he wrote where he has three characters debate geocentric versus heliocentric models for the universe. The universe at this moment is the whole is just the solar system, right? I think, so he's good at communicating, but maybe not so politically savvy, because he called the philosopher that was debating for the geocentric universe Simplicio, which I just think is, maybe a little bit on the nose as to what your viewpoint is. But in any case, one day I'll read this properly, but it's just a charming idea of how to present science in this play. So Kepler gets 3 books in the library because 3 laws, although it turns out the first book didn't have any of the laws, the second book had 2, and then the third book had 1. But the first book's still significant because it kind of brought Kepler to the attention of Tycho Brahe, and they had this conversation about how they needed to use observations of the motions of the planets to really develop the model. Kepler, of course, is the, planets are on orbits, and the orbits aren't circular, they're elliptical and equal area in equal time, and then how the period and the distance from the sun relate to each other. Still things we teach in introductory astronomy today. And a lot of that based on Tycho Brahe's observations done from his observatory, which I showed you before. This is a map that shows the gardens as well. Must have been a really beautiful place. Too bad it got destroyed. But... Okay, this is one of my favorite illustrations in the book from Doppelmayr. It's again one of these big, beautiful atlases showing kind of the understanding of astronomy, this time in 1730. I really just enjoyed this. It's so much detail. If I had time, I would just go into so many things about this were really fun, but I particularly got interested in this top right corner, and I'll blow it up, although it's kind of a blurry version. You can find a beautiful, clear version online and look around. And you can also either find a friendly classicist or try Google Translate. This is in Latin, the words here that you can't read because they're blurry anyway. But look at this, we've got lots of little solar systems floating around. And actually, I think I put the words here, paraphrasing, in this text is a statement that a cannonball, since a cannonball would take 25 years to reach the sun, we can use it to consider how far away these stars are. And they're so far away that a cannonball will take 700,000 years to traverse. It's actually a bit less than it, but still roughly 700,000 years. And I just thought this was charming, the use of cannonball speeds to, illustrate large distances. A nice example of the kind of thing we try to do today. Okay, so we're going to move on a little bit. We're nearing the end here. We're going to start to bring some mathematics into astronomy. Isaac Newton, of course, is Principia. The only illustration in that, apart from like some geometry, angles and things, is this fold out showing the path of a comet. in the year I always lose. Does it have the date? Anyway, this comet that comes in, and the parabola here is Newton's prediction and showing the comet precisely moving out as per his prediction. And so we're sort of starting now to understand astronomy with mathematics and being able to really predict the motions very precisely. There was this whole kind of explosion of books about the mathematics of astronomy. This one was published in Spanish, talking about the mathematics of the universe being the highest level of mathematics there is. Lots and lots of books published for navigation. So this one was kind of fun. Jerome and Marie-Jeanne Lalande. Marie-Jeanne actually didn't get credit at the time, but there's a lot of work that suggests she did do a lot of the work that was in the book. And then my personal favorite, Mary Somerville, who I think you heard about fairly recently. I just really enjoy reading about Mary Somerville and the work she did translating calculus into a textbook that was used at Cambridge for, I think, something like 50 years, and also her connection of the physical sciences, which kind of defined physics as a subject and all other kinds of cool stuff. Mary Somerville gets an invite to my imaginary dinner party. I want to have a conversation with her. And then we have all the textbooks and the fun books about astronomy for a more general audience, and these just charming illustrations. I really love this one of the phases of Venus. Next time I teach about this, I'm totally using this illustration. And I was pretty astonished to find out how early spectra are getting into astronomy books intended for popular audiences. So this, and for children. So this Story of the Heavens is a book for children, showing the spectra of the sun and some stars in 1885, which is, it's pretty cutting edge stuff at that time. You can't mention textbooks about astronomy without mentioning Sacrobosco. And there's maybe you've already had a talk on this, but I watched a YouTube talk, I think Mike Edmonds maybe, talking about how this is the most popular book in astronomy ever. And certainly many, many thousands of copies were published. It's this charming little book. We have a copy at Haverford. It's very, very little. And they're all different, slightly different editions. It's a very geocentric universe that's presented. It was written pre-Copernicus, although it was still being published long after Copernicus. By Sacrobosco, who may or may not have been British. That's somewhat unclear. Gotta mention that. This is another cool one. So James Ferguson, roughly 100 years after Newton, published a book about astronomy explained using Newton's principles. So it's sort of a textbook for young people to explain Newton. And supposedly William Herschel, it was one of the first textbooks he used to learn about astronomy. So I thought that was quite neat connection. And it has all these beautiful illustrations of mechanical orreries and other things like that James Ferguson made. So I really enjoyed that. This picture is not from this book. It's just one of the illustration of the Herschels that I presume you've seen before. And then just to kind of almost end here, I was also really struck by how many books are written by and for women in this period. So 1859, Telescope Teachings by the Honorable Mrs. Ward, 100 years earlier almost, or I guess 60 years earlier, 1797, we've got Mrs. Bryan and her children, and she ran a school and taught astronomy to numerous young women. So I was just really struck by this because it's not something I'd heard about before, how many books about astronomy are by and for women in this early period. And then the last one I have is The Heavens and Their Story by Annie and Walter Maunder. Probably heard of the Maunder minimum and the solar cycles. They're very famous for their work on that, using early photography. And so this is one of the first sort of textbooks or popular science books that includes a lot of photographs. I thought that was neat, and these early photographs of sunspots. So since we're talking about the history of astronomy, I'm going to be a chicken and avoid talking about books in the last 100 years, just sort of reflecting that, a lot of the books that I collected were really like cutting edge, the new ideas in science. And that's really not how we publish new ideas in astronomy today. Very much the new stuff is going in journals, and that's been true for probably more than 100 years at this point. So really all the books that are published are textbooks or popular science books. And also was reflecting on sort of the change of technology and how that's changed what's in books. If you ask, I'll tell you about some of the books, but otherwise I'm just going to end here. And I hope you enjoyed hearing about the books. I had fun learning about them. So
Excellent. Let me just.
Thank you.
Yes. Excellent. Thank you so much, Karen. I would say I got a copy for my birthday, so I've been taking a look through it. It really is sumptuous, isn't it? Really gorgeous to hold and to.
Yeah. It's very much a book you want a physical copy of, I think. So I was saying, you know, I mostly looked at books online for doing this, but there was something special about the ones that I could go and see in person. And I actually ended up buying a couple, not the really expensive ones, not yet at least, but some of them.
You haven't got your own personal copy of Day Revolutionary with us yet.
No, but I can go and see it anytime I like.
Yeah.
So yeah, so.
Yeah, again, you were talking about Owen Gingerich, who wrote that amazing book about going seeing all the copies of Day Revolution with us around the world. So it presumably came to your observatory.
I assume so. It's not that book is in our main library, so it's not in the astronomy library here. But that's a good choice because they have all the like climate controlled stuff, and yeah, we have fairly old books actually. I would say, you know, certainly books from 1900 or so. I think there's probably a research project in looking at what the books are in our library and how, but I don't know. I had some students once as sort of a Fermi project, you know, this estimation. We try and teach students to estimate, don't just Google it. You can figure out for yourself how many books are in the library. How long would it take you to read all the books in the library? And the answer is it's a really long time. And there's a lot of books, even in this little library. So yeah, more than 100, that's for sure.
Okay, so let's see how we do questions. You can either put them into chat or signal that you'd like to ask a question and then unmute yourself. So any questions? I'm trying to monitor all everybody here, so it may be a bit tricky. If I don't see any questions. Go on, Carolyn.
Thank you, Karen. That was a fascinating talk. I was very interested about your reaction to seeing the Andromeda galaxy represented in the nose of the Arabic manuscript. Was there anything else that was really surprising, which you came across? I'm sure there was other things, but was there anything else which comes to mind that really surprised you that you hadn't known about before? And goodness, I didn't realise they knew that or something like that.
Yeah, I mentioned a few things as we went along, but I saved one because someone asked me this before, actually. And I'm a galaxy person. And so I always I try not to mostly have galaxies in it, but I picked out some of the galaxy stuff. So I mentioned I really got struck by this Other Worlds Than Ours, Richard Proctor. And I was looking at this for the planets, right? For the maps of other worlds. But it had a section called The Nebulae, Are They External Galaxies? And I was like, hang on a minute, this is 1870. This is 50 years before I was learning that we were doing this, right? I'm learning, what I've been taught is the Great Debate in the 1920s between Harlow Shapley and Heber Curtis. But this is, well before that, this debate. And not only was there stuff about whether the nebulae are external galaxies, there was also this pretty accurate map of the Milky Way. I mean, it's not quite what we think the Milky Way is, but it's this very sort of flat map.
Looks more like sliced ham than
it does
fried egg.
Yeah. It's very hard to draw pictures of galaxies. I don't know if you've ever tried, but I've become more and more impressed by Lord Ross's artistic skills the more I think about this. But also so Proctor is also pulling in spectroscopy, which I thought was cool. So the reader will see how the spectroscope can resolve the question as to what nebulae are made of. So you can use, what you view in a spectra to tell whether or not it's a continuous light, or it's light that's coming through a gas, so you get absorption features, or light coming from a gas, so it's all emission features. And so it's reflecting that. The spiral nebula seem for the most part to give a continuous spectrum. So it's stars, right? It's light from stars. So they kind of knew, even well before the Great Debate, that the spiral nebulae must have been collections of stars, which I was just surprised to find how early that's in. I mean, and this again, it's a popular science book. It's not a book published for research. So yeah.
Thank you. I will say Richard Proctor, he had a daughter called Mary who produced quite a number of popular books, and she fits almost into that slide where you have the ladies producing, but a little bit later the popular books. So I don't know if she was a bit too late
I think
to drop
Mary
into
Proctor,
your, yeah.
I think she was was she Telescope Teachings? No, that was a different one, wasn't it? I think I did have a Mary Proctor book.
Romancing the Moon and romancing various things, and yeah, she did
She
a
might have
number
been
of
The Story
talks.
of the Heavens. I should have put the names as well. There's so many books and so much stuff in this. I must admit that I can read this book now and be like, oh, I didn't remember that I knew that. But it was kind of a quick process. So
Thank
David.
you.
Yeah,
David,
thanks, Karen, for that interesting talk. Just before I ask my question, whilst you were talking about Owen Gingrich and your copy of Copernicus, I looked at some photographs I took of the index of his annotated census, and Haverford was in there. So presumably he did visit or get information about it. A lot of the books you talked about and a lot of the books in the history of astronomy are beyond our reach because they're in classical languages like Latin or ancient Greek or maybe Arabic, which fewer and fewer people are conversant with. Did you form a view as you were compiling this book on which historical books really stand urgently in need of being translated into English because they're so important or interesting, or would be, to modern astronomers or historians?
I did think that probably some of the Islamic texts have been a little bit understudied. And so certainly that is something. And those are also, I mean, I ended up reading a book called the Timbuktu Manuscripts in the process of working on this book. And it's a book about saving this set of manuscripts from Timbuktu from the Islamic jihadi coming in and saying, you know, want to destroy all of the records of historical stuff that didn't agree with their world viewpoint. And so there were these incredible efforts to get these manuscripts out of the dangerous area, and like, you know, sort of adventure story of taking them on boats down the river and all this stuff. It was very little about astronomy books in it, to be fair, but nevertheless interesting to read. And there was one book from that I mentioned, but I don't know how much work has been done to really understand the astronomical significance of those. I tried to reach out. So Timbuktu's in Mali, which is in Northern Africa. So I tried to reach out to some African astronomers I know, mostly from South Africa, because, you know, there's big telescopes in South Africa now. Unfortunately, I didn't get any takers, but I do think that there's probably some research in astronomy history on the astronomy in the, you know, from medieval Islamic world in Northern Africa that's been kind of understudied to date. So there's, interestingly, I mean, Haverford has classicists and has the religion department. One of my colleagues here, just for fun, is learning Arabic. So, but I don't know very much about Arabic and how, you know, I know that classical Greek is pretty different to modern Greek. I don't know if classical Arabic is different to modern Arabic. I'm woefully uneducated on that. So,
Thanks.
Any more questions? I think the one I'd love to know more about is the Dresden Codex. That must be so culturally different to every.
Yeah, I agree. I think it has been studied quite a lot though. So there's some pretty extensive papers on the astronomy in the Dresden Codex that I read parts of. I'm going to admit I didn't even read the entirety of the papers on them because they're pretty long, and they have lots of translations of the hieroglyphs and lots of like mathematical analysis of the numbers and what things are happening. Maybe they could use a revisit with a more modern eye. I don't know. A lot of them were sort of somewhat older studies, so maybe I don't know, but yeah, it's certainly fascinating. It was so like heart-wrenching to realize that only 4 books were saved from this entire culture. We don't even know how many books they wrote. Like, I found that, I mean, obviously all the people that died is very sad too, but
like the destruction of the Alexandria Library.
Yeah.
But that's why we have libraries, is to try and hold on to things. Any more questions? Apologies if you're trying to scan all the people here. I'm trying to make sure I get to everybody.
I can meet.
There's nothing in the chat either, Mike.
Yeah. Okay. Shall we, unless we've got any more questions, shall we bring things to a conclusion? So to say thank you so much, Karen. That was wonderful. Lovely tour through the history of astronomy books. And as I say, it really is a lovely book. So if you're looking for something to either ask for your Christmas present or to buy for the astronomer in your life, then it's definitely worth investing in. Can I say, coming up, we have a couple of meetings. A week on Saturday is our annual general meeting at the Birmingham Middle Institute in Brum. I'm one of the speakers. We've also got Simon Banton talking about Stonehenge, Ellie Evans talking about the stone circles of Cumbria and their astronomical significance, Beatrice Steele talking about Norman Lockyer's eclipse expeditions. And our next webinar, I do believe, I should have looked at it before, but I think it's Wednesday, January the 15th. Professor Anna Marie Roos from the University of Lincoln here in the UK, although I think she is American originally, will be talking about the Annus Tenebrosus, the solar eclipse of 1652, mainland Britain's last but for total eclipse, mainland Scotland's last total eclipse of the sun, which conveniently arrived in the middle of the Civil War. So you can imagine people taking sides over it. So we've got some excellent things coming up. But thank you so much, Karen. It's been a great evening. Thank you all.
Thank you, Karen.